All right, folks, if you're watching this video, this means I can't be here with you today. I picked this unit to be our lessons to do when I'm not here because they're really nice because they can be done alone or they can be done together. So the chapter can be broken down into pieces or it can be put all together. Normally I teach it all together, but we're going to break it into pieces. So we're going to talk about arithmetic sequence. All right, so remember that brightly colored, ooh, that's bright. The brightly colored sheet that I gave you, I believe it was green. It looks really yellow here, but I promise it's green. If you go partway down, you're gonna see arithmetic sequence, there's a geometric sequence, there's an arithmetic series. There's two options here. There's geometric series, there's this option or this option, and the last one is the infinite series over here. Okay, so these break up into 5 lessons. Today we're going to do arithmetic, and then there's a geometric sequence. Arithmetic again, but this time it's a series. Geometric means, series as well. And the infinite is your 5th lesson. So those are the 5 lessons. So you always have these equations with you. If you forget them anywhere, ooh, I changed the brightness of it so you guys can see it better. So yeah, just know that you've got them on your formula sheet if you were doing this assignment and you don't have your notes with you. Okay, so let's go through this really quickly. Arithmetic means that we are adding or subtracting. Adding or subtracting there. And sequence is a set of numbers. So we know that we can get, I'm going to switch to a different pen. We know that we can get all kinds of sets of numbers, all kinds of different numbers, all kinds of things together. But the reason why they're special is because we're going to add or subtract something to get to the next number in the set or the sequence. Okay, it's an ordered list of elements. They go in order. Order is really important. Elements are just the numbers in the set. The elements in the range, we call these things terms. So if I had 1, 2, 3, we separate those by commas to indicate that they go together, but they're not 123. It's number 1, 2, and 3. And I'm going to put an ellipse at the end of this. Ellipse is 3 dots, and what that means, it continues on forever. Okay, so we know, you're like, Scallion, this is just counting, and it's true, but it is an arithmetic sequence because if I take 1 and I add 1 to it, I get to 2. If I add 1 to 2, I get to 3. Add 1 to 3, I get to 4, and so on and so on. So, although it looks like it's counting, it really is arithmetic sequence. I mean, there's lots of them. 2, 4, 6, 8. That is, you're adding 2 each time to get to the number. We could start at 7 and go 11, and then 15, and then 19. And if you were to think about that, 7 to 11, that's 4. And then I add 4 to get to 15, and 15 I add 4 to get to 19, and so forth and so on. So it's just a pattern of numbers. So I like this because it's nice and easy. The equation, so it's a lot of algebra work. Oh, this looks really weird. I changed how it's supposed to look and my hands look weird. So this is Tn equals T1 plus bracket n minus 1 times d. So it's a lot of algebra work and you need to be careful with your order of operations. So again, you've got some stuff to do in the brackets and then you'd multiply it by d. Okay, so let's go through all the terms. So Tn is the value of the term you're looking for. Okay, so Tn, so like if I was looking for the 10th value, we'd substitute 10 in here for the n. T1 is the value of the first term. I can say it faster than I can write it. N is the number of terms and remember terms are just the numbers. So in this one, if I didn't have the ellipses, this would be 3 terms because I have 3 in my set. Okay? N's the number of terms. What else am I missing? Oh, D. D is the common difference. So what is it that you are adding to get to the next number? So what about this sequence? I'm just going to write it right here. What about this sequence where 10, 5, 0, -5? So the common difference for this one, as you can see, I'm actually going down. So to get from here to here, I have to subtract 5. To get from here to here, I have to subtract 5. From here to here, I have to subtract 5. So my common difference in this one, I would say that D, because it's a subtract 5, it's -5. It kind of makes sense, but some people miss that. If you're adding, like for this one, we were adding 1, my common difference here would be a +1. Okay, so if you're adding to get to the next number, it's a positive. If you're subtracting to get to the next number, it's a negative. So hopefully that makes some sense. Okay, so we're gonna find T20. So remember, that's just our Tn, right? We're just replacing the n with the value. Well, we're trying to find the 20th term. What's the value of the 20th term? That's what the question's asking you to do. Now, you could actually go and start working it out. So first thing I do is 5 to 8, I'm gonna add 3, 8 to 11 is +3. So I know I'm adding 3. So I could keep going and adding 3 until I get to the 20th term. You can totally do that, but it's not efficient. And as mathematicians, we try to do things efficiently. And it's really easy to make what we call a transcription error, where you add it wrong, 11 plus 3 gives you 13. That doesn't mean that you don't know what you're doing, it just means you were rushing, and if you're doing a lot of them, what if I put 200 here? That would be a lot of math just to add out all those terms, or we have a formula that can do it for us. So we're trying to find the 20th term. So I like to do this, T20. I don't know what it is. What's the value of the first term? Well, it's given in the sequence, so the value is 5. N is the number of terms, so that's supposed to be a 20, not a 26, just in case anybody's wondering. So N should match this, so that's 20. And my common difference, what did I have to do to get from 5 to 8? Now here's the thing, if it doesn't pop off the page at you, which I mean, obviously this one we're adding 3, that's not a big deal. But if it were fractions or something like that, so to find the common difference, take term 2 and minus term 1 from it. So the common difference would be 8 minus 5, and that would be 3. And that will always work, so that if it's something that doesn't pop off the page, I find fractions, sometimes my mind doesn't pick them up right away. It makes more sense to actually do this to calculate. So you take the second term and minus the term in front of it, or you could take the third term and minus the second term, but they have to be consecutive terms. Consecutive just means in a row. Okay, so the formula is T1 plus n minus 1 times D. No, you do not have to write out the formula. I'm just writing it out because the more times I write it out, the more likely it is that my brain is going to remember. Brain's getting older, so I'm going to try to do whatever I can to make that work. So I'm doing order of operations. So I did what was inside the bracket first. 20 minus 1 is 19. And then I go ahead and I multiply these. So I believe it's going to be 57, but I just want to double check on my handy dandy calculator. 3 times, didn't put the time symbol in there. 3 times 19, 57. Okay, I'm getting better with my math as I get older. Do you know how I did that in my head? I said, okay, what's 3 times 20? That's 60. This was 1 away from 20, and I had 3 of those, so 60 minus 3 is 57. So that's what I did in my head. So the value of the 20th term was 62. And that would be my final answer for this question. So again, using the formula, it's just really easy, quick way to find the value of future terms. Okay, so that's page 1. Oh, I have so many examples. There's 3 pages to this. Find the formula for the nth term. So, oh, sorry, you can't see that. So you are making a general formula. So anytime I ask for something to the nth term, you're making a general formula. Okay, so it's an arithmetic sequence, that's good, whose common difference is 5 and whose second term is 12. Okay, so let's write down some stuff that we know. Tn, we're never going to know. T1, don't know that either. I know the common difference is 5, and n is going to stay n, because I'm making a general term. So when I do a general formula, this and this will stay as letters. You're not solving for this one. You're making a formula. They stay as letters. Okay, so what I need to know is I need to know what term 1 is here. But it gave me some information. I don't know T1, but I know T2 is 12. I know that the common difference is 5, so I know that T3, 12 plus 5, is 17. I know that T4, 17 plus 5 is 22. So I can keep going forward. So if going forward I'm adding 5, what am I doing when I'm going backwards? I'm subtracting 5. So my first term is going to be 12 minus 5, so that'll be 7. Okay, so I now know that that's 7. So I had to do some thinking. I like this unit because it makes me think, it makes me problem solve, and I get better at doing my order of operations. So I'm going to use my formula. Tn equals T1 plus n minus 1 times d. And again, I like to always write down the formula for me. It helps me remember. Remember that Tn is going to stay a letter, so we're going to leave that. Tn equals 7 plus n minus 1 times 5. Okay, so you're like, I'm done, no big deal. Here's the thing with formulas. This is only going to get you to partial marks. Now you actually have to do the math and tighten it up, make it look nicer, do any math that can be done, and this distribution can be done. So we're going to multiply the 5 into here and here. So I've got Tn equals 7 plus 5n minus 5. Okay, not done yet because I can combine the 7 and the negative 5. So Tn equals 2 plus 5n. This is the general formula I'm looking for. So if you stop at this step, I'm going to put a sad face here. If you just stop at this step, then you're not going to get full marks for this. Okay, so you've got to do the math and you've got to get it as tight and as concise and succinct. That's a fancy word for brief, and I'm not very good at that, as you possibly can, mathematically speaking. Okay? This one will be on your quizzes, on your tests. We're not doing quizzes in this unit, I don't think, but it will be on your test for this. I guarantee you I will make you create a formula, a general formula. So remember when I'm asking for the nth, scrolled up too fast, the nth term, I'm asking for a general formula. I just realized I didn't spell formula right. I knew it looked weird. Okay, find the 18th term of the sequence from example 2. Perfect. So I'm going to use the formula that I solved for. I know that Tn, I'm looking for the 18th term. I know all I really need to know is n now. And I'm looking is 18. So I'm going to use my formula. Tn is equal to 2 plus 5 times 18. So 2 plus 100 minus 10 is 90. So Tn is going to equal 92. Let's just double check my math on that. Okay. Okay, so that was great. I used my formula from here. I used it. It was really easy to do. But if you don't have confidence in this formula that you just used, you can still go back and use your other ones. So we knew that Tn, we don't know. We knew that T1 was 7. We knew our common difference was 5, and this time we knew our n was 18. So we can go right back to our formula. So 7 plus 18 minus 1 times 5. So Tn equals 7 plus 17 times 5. So 85 here, so 7 plus 85. And then if I do that, Tn equals 92. So I get the exact same answer. So using the information I knew from example 2, I could go right back to the formula that was on my formula sheet and go from there if you weren't confident enough to do it from the formula that you created. Notice that this was a lot faster because you did all that math already in theory up in this question. You did all that. You distributed the 5 through. You combined terms. You did it all. You just redid it if you did this option here. So super exciting. Okay, so if you need to pause or stop the video, or if I'm going too fast, just remember it's a video. You can play it over. You can pause it. You can do whatever. And if you're not happy with that, then we'll go from there. Okay, how many multiples of 9 are there between 100 and 500? Okay, so first of all, let's talk multiples of 9. So multiples of 9 are things 9, 18, 27. They're 9 times 1, 9 times 2, 9 times 3. But the thing is I gotta figure out which one is less than 500 but greater than 100. So we know that we'll put some ellipses in there. So 90, 99. What comes after that? 108. So my first multiple, so if my boundaries are 100 and 500, my first multiple is 108. Okay, that's there. Ooh, sorry, there was a 500 over there. So now the question is, what's the one that's less than 500? What's inside this boundary? If this was a number line, we know that 108 would be here. What's this one closest to 500? So using my handy dandy calculator, I'm going to do some guessing and checking. Oh, look, that shows up pretty good. So I know that this one is, that's 11, that's 12. So what if I did 15? 15 times 9. Ooh, not even close. I got to go bigger. What's 20 times 9? Oh, I got to go way bigger. So let's do 50 times 9. Oh, 450. Okay, I'm getting closer. So 52 times 9. 468. Okay, I'm getting closer. 55 times 9. Oh, 495. I bet you that one's it, but I'm just going to double check. 56 times 9. Okay, so we know that the closest number to 500 is 495. All right, so what was the point of that? This is my first number, so guess what that is? That's T1. This is my last number, that's Tn. So what we're asking for is how many? So what we're asking for is we're solving for n in this equation. That's what we're solving for. N tells us how many terms there are. So I know that Tn has a value of 495. I don't know what n is yet, so I can't fill that number in. I know that T1 has a value of 108. I know that the common difference is 9, right? Multiples of 9 must mean we're adding by 9 each time, right? And I'm trying to solve for n. So I'm going to use my formula. So Tn equals T1 plus n minus 1 times d. So 495. Remember, I'm putting these in where I see them. So Tn, 495. T1, 108. N minus 1, I don't know. I know d is 9. Oops, I got a plus sign in there. That would have been travesty. So distribute that 9 through, because the order of operations says I'm going to do any multiplying. So I'm going to distribute. It's weird distributing backwards, but we're good. We got this. 108 plus 9n minus 9. So I'm going to combine these two. So I have 495 equals 99 plus 9n. So now it's just a two-step algebra equation, which we all should be pretty comfortable with. So yeah, let's do some math. Minus 99 from both sides, minus 99 from both sides. So that would be 396. $396 equals 9n. Divide both sides by 9, divide both sides by 9. And n is going to be 44. So that means that how many multiples of 9? There are 44 multiples of 9. Pretty straightforward, and it's just manipulating the formula. So it's a really heavy algebra-based unit. Nice thing is we're not graphing in this unit, so enjoy it. Okay, the last one. Ooh, my pretty picture. John has been given the task of stacking cans in a similar design to the picture given. The number of cans in each row produces an arithmetic sequence. Perfect. The first top row, 4 rows are as shown. There are 14 cans in the 8th row, the 8th row from the bottom, and 10 cans in the 12th row from the bottom. Determine T1, D, and Tn for the arithmetic sequence. All right, so let's figure it out. So is this my first row or is this my last row? And think about it logically. You're like, it's your first row. But think about it logically. When you're stacking cans, you don't put this can and have it float in the air. You start at that bottom one here and build up from it. So we know that our Tn, our last one, is going to be that single can. Okay, we don't know what T1 is. That's the confusing part. The number of cans in each row produces an arithmetic sequence. Okay, what do we know the common difference is? We know that. Common difference, so we had 4 in this row, 3, 2, 1. So we're counting. So if I wrote this out, we would have 4, 3, 2, 1. And I guess there's more to that sequence in front. So that means we're going down by -1. And we don't know how many rows we have. All right, but it tells us some stuff. It tells us there are 14 cans in the 8th row from the bottom. 8th row from the bottom. So we're going bottom. Okay, so first row, second row, third. Oh, I'm writing way off the page. I'm sorry, guys. 4, 5, 6, 7, 8. In this row, there are 14 cans. And then it tells us that there are 10 cans in the 12th row from the bottom. So 9, 10, 11, 12. There are 10 cans. Which makes sense, right? Because now I'm saying first row from the bottom. This is a big contender, the language of this. I'm saying the first row is the bottom. Other people will say, nope, there's another row. There's like row 0. But this is the information. This is how we're going to solve all this. We're actually going to use, let me grab a different color. We're going to use this information. We're going to use that little piece of information that was given by the equation to solve for all the rest of this. This is what's really neat. The pattern is the exact same no matter where you are in your sequence, no matter where you are in the terms. The pattern doesn't change. So what I'm going to do is I'm going to make this one the fake T1. And I'm going to make this one the fake Tn. All right. You know what? That's only going to tell me the common difference. Okay, I know that already. Now we got to figure it out. Well, we can figure this out. Well, geez, I don't even think we need to. Do any math. I think we got to count. So if going up, we would say this one has 13, 12, 11, and then 10, right? So if going up, we're subtracting 1. Going down means we'd be adding 1. 18, 19, 20, 21. So T1 is 21. Now the question is how many rows in total? Well, let's keep going. 1, 2, 3, 4, 5, 6, 12. Remember that we got to get to can number 1. So this is going to be the 13th row is going to have 9. The 14th row is going to have 8. The 15th row is going to have 7. The 16th row is going to have 6. The 17th row is going to have 5. The 18th row is, oh look, it's going to have 4. That's pretty cool. 19th row is going to have 3. The 20th row is going to have 2. And the 21st row is going to have 1. So n is also 21. That's pretty exciting. So we didn't actually use any formulas here, we just used some math. This makes more sense to me to reason it out this way when it's a pictorial thing. You probably could have used the formula to figure it out, but I think we would have had to, I don't know, I think we would have had to work backwards. Oh, I know what we could have done. Silly girl. Never mind, I know what we could have done. Let's do it mathematically. Okay, so let's go back and use this information. It doesn't really matter which one. Let's grab this. So let's use this as, let's do the 12th row. So we know the 12th row is 10. We know, we're still looking for T1, which is question mark. We know that the common difference is -1. And we know in this situation n would be 12, because I'm just looking for, we know this information. So on the 12th row, it would have a value of 10, and we know we have 12 rows. So if I use my formula, 10 equals T1 plus 12 minus 1 times a -1. So 10 equals T1 plus 11 times -1. So we have 10 equals T1 minus 11. I'm getting excited, I'm doing my math early. Plus 11 to both sides. So T1 has a value of 21. Oh, silly girl. So we could have done it mathematically as well, or we could have done it spatial reasoning. Either way, if you were to do this on a test, you'd need to show me your entire spatial reasoning. There has to be something. I would suggest that if you're going to do it this way and not formula way, that you write an explanation to go with it as well. So that's your lesson for arithmetic sequence. You have the assignment that goes with it. The answers are at the bottom. If you need anything, shoot me an email. Thank you, and hopefully we'll see you soon.